Alright, so today we're going to be filling out this chart and also the day 3 video notes. So if you need to pause the video, go ahead and fill out the chart. What you're going to be seeing besides square roots now is you're going to be seeing something called cube roots or fourth roots or fifth roots or really any root. You'll probably see square roots, cube roots, and fourth roots the most commonly in these problems. Alright, so I will leave this up here. You can pause it and then write it down, and then we'll come back to how to do these on our calculator in a minute. Alright, so things for our notes. You need to know that when you see a square root, if there's no number here, it's implied to be a 2. But otherwise, there will be a number there, and that number is called your index. What you see here is a radicand. So in the problem, square root of 9, even though we don't see an index there, we'll say this is an implied 2. Right? Our index is 2 and our radicand is 9. When I see something like the cube root of 27, what that means is what number times itself 3 times will give you 27. So just like here, a square root really means like 3 times 3 is 9. That's why the square root of 9 is 3. Here, this is referring to 3 times 3 times 3. So if I took a number and multiplied by itself 3 times, if I did the cube root of 27, that's equal to 3. If I do a fourth root of 16, that's asking me what number times itself 4 times will give me 16. Well, think about it. It's 2 times 2 times 2 times 2. So the fourth root of 16 is equal to 2. Now, technically, you could also have negative 2 times negative 2 times negative 2 times negative 2. That would equal 16. But when you see this symbol, we just take the principal root, so you just put the positive value out there. Unless there happens to be a negative sign on the outside, then you would write it down as negative. That's for even roots. But we'll get to ones like that as examples later. All right, so another thing you need to know is if you want to multiply or divide any radicals, you must have the same index, meaning all the radicals in the problem all need to be square roots, or they all need to be cube roots, or they all need to be fifth roots, whatever the case may be. And then you can multiply or divide as needed. And we would multiply our radicands. All right, if there's any additional notes, we can come back and add those. All right, so back to this chart. How do you do some things on your calculator? So we all know how to do a square root, right? If we just saw the square root of 81, this is the math menu, so we'll come back to that if we need it. But we're going to just do second and take the square root of 81. Right? We know that that's 9. If we want to do the square root of 36, you just do that. Okay. If I want the cube root, however, that's where I need to go to my math menu, and there's a cube root key right here. So if I want the cube root of 8, that wants what times itself 3 times will give you 8, and that's 2. Now, you can also do the cube root of negative 8. So you do math, you do the cube root of negative 8, you get negative 2. And the reason for that is negative 2 times negative 2 is positive 4, times another negative 2, that gives you negative 8. So this equals negative 2. However, if I were to do the square root of negative 36, that's not going to be negative 6. Right? That's 6i. We talked about that last semester where you have imaginaries. So cube roots and fifth roots and any odd roots, if you take a cube root of a negative, you get a negative. If you take a cube root of a positive, you get a positive. Okay? So if you wanted to do cube root of 729, you get 9. All right, so then here's another one, a fifth root of 243. So if I want something other than a cube root, I'm going to look at this button. So if you hit math, I need to pick the xth root. Now, I have to actually type in my 5 first. So if I want a fifth root, I type in 5, and then I go to math, and then I go down here. So I would do the fifth root of 243, and that's 3. So that means 3 times 3 times 3 times 3 times 3 is equal to 243. So the answer is 3. All right, so going back to our problems for today, you have to simplify. It says square root for this one, cube root for this one, and fourth root for that one. So even though those index numbers are little, they're very important. So don't ignore those. All right, so when you do these, I would simplify the first thing as square root of 16. So just what is the square root of 16? We know that that's 4. If you don't know it, you can refer back to the square root. Square root of 16 is equal to 4. Okay, now x to the fifth, think of this as x times x times x times x times x. So when I am taking a square root, I want to think of how many groups of 2 can I take out of here. So I can take out 2 groups of x's, but then this one is left over, and so that has to stay on the inside. So this would be 4, and then x squared times the square root of x. All right, here we're going to do the cube root of 16. So the cube root of 16 is not here. So in this case, we need to break it up. Is there a cube root that is on my list that's a perfect cube that can go into 16? So the only thing that could go into 16, it has to be less than 16, so that would be 8. Right? And if you think about it, 8 times 2 is 16. So I split that up. Just like I would split up any radical, these just happen to be cube roots. So what is the cube root of 8? That's 2. This one stays on the inside of the radicand. All right, so now I've got x to the 6th, and I'm taking the cube root this time. So I want to know how many groups of 3 x's can I remove. So 2 groups, which means that I've got x squared on the outside, and there are none left over. So my answer is 2x squared times the cube root of 2. All right, number 3. This is a fourth root of 16. So is that a perfect fourth? Yeah. So since it's on my list here, it's fourth root of 16 is 2. Now you can just do it in your calculator. Oops, sorry, I need to type in the 4 first, then go to here, do the fourth root of 16, and that's 2. All right, so that goes on the outside, and then look at my x's. I have 5 of those, 4 y's, and it's a fourth root, right? My index is 4, so I need groups of 4. So I have 1 group of x's, 1 group of y's, but I have this lone x that's left over, so that guy has to stay on the inside. So it's 2xy times the fourth root of x. All right, so flip to the other side. I think the multiplying and dividing actually will be tomorrow, but you have it written down anyway. All right, so we look at cube root. Can we take the cube root of 27? If you want to refer back to your chart, you can. Otherwise, we'll take the cube root 27. That gives me 3. So I know this becomes a 3, and then I have 6 x's. This number in my index tells me how big my groups need to be. So I've got x squared, and I took everything out. This became a whole number. There's no x's remaining, so I'm all done. Okay. All right, this one, cube root of negative 54. So if I try and take the cube root, that's cube. I need to choose number 4. Cube root of negative 54, I get a decimal. So that tells me that I don't want to write down what I have in my calculator. So I'm going to refer back to this list, and I have my cube roots here. Right now, unfortunately, 64 is on the list, but not 54. So that tells me I need to break this up into the cube root of something times the cube root of something. So does 27 go into 54? Well, 54 divided by 27 is 2. So that's convenient, right? Found it on the first try. 27 times 2. Now this negative sign I'm just going to put with my perfect cube. So what is the cube root of negative 27? Well, it's negative 3. So we have negative 3. This cube root of 2 stays on the inside. And then I'm going to expand my x's. Hopefully you're finding the pattern here. So I've got x to the 6th. I need groups of 3 this time, right, because that's my index. So how many groups of x's? I have x squared and y to the first. No x's are left over, but I have 2 y's left over. So now I have negative 3x squared y, cube root of 2y squared. All right, so hopefully you picked up on the shortcut. If I've got x is 6 and I want to take out groups of 3, you can do 6 divided by 3. That gives you 2, so that's why there's x squared. 5 divided by 3 gives you 1 with 2 left over, so those 2 left over stay on the inside. All right, what's my index when I don't see one? So it's the implied 2. So that's asking you what's the square root of 36. Well, if you don't know the square root of 36, that's 6. Okay, so that's negative 6 because there's a negative sign out there, and I have 1, 2, 3, 4 y's, but 4 divided by 2 tells me I should be able to take out 2 groups. And sure enough, I have 2 groups with nothing left over. All right, 3 more problems. So I have a fourth root. 48 is not a perfect fourth. If I try to do it on my calculator, I get a decimal. So that tells me I need to look at a perfect fourth that can go into 48. All right, so think about what can go into 48. Well, there's not too many things to choose from. There's just 16 and 1. It's probably not going to be 1. All right, so divide 48 divided by 16, you get 16 times 3. And then I've got 13 x's. All right, so we've got fourth root of 16, that's 2, but the fourth root of 3 stays as is inside the radical. Now, since it's fourth root, I need groups of 4. Here's my third group. So I've got x cubed and just 1 x left over. If you do 13 divided by 4, you get 3 with 1 remainder, which is why the 1 is left inside the radical. You don't have to write these out if you could do that in your head. All right, so we've got no coefficient here, so we'll just think of 18 divided by 6, that's 3. All right, so it's x cubed. 10 divided by 6, you can get 1 group out, but there'd be 4 left over. Okay, so if you can't do that in your head, you can write out, you got 18 x's. Okay, so I've got 1, 2, 3, 4, 5, 6. I took out all my x's and I have 10 y's. Okay, and I look for how many groups of 6. Oh, sorry, this one I didn't do right. Looking for 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 18. All right, groups of 6. Sorry, I did groups of 3 over there. So I have 1 group of 6, 2 groups of 6, and 3 groups of 6. So that's why that's x cubed. And here, for my y's, I want 1 group of 6, plus there's 4 left over. All right, so last one, we're looking for the cube root of negative 40. Well, that gives me a decimal. So that tells me I need to break it up into the cube root of something times the cube root of something. Now I know I'm going to put the negative with the perfect cube. So cube root of 40, 40 is not a perfect cube. Does 27 go into 40? Well, nope. And 40 divided by 8, that goes in. So it's 8 times 5. So I'm going to think of cube root of 8 times cube root of 5. Well, the cube root of 8 is negative 2. Cube root of 5 is what stays inside the radical. And I've got 8 x's, so I want groups of 3. I've got 1, 2, but not enough for a third group. So I have x squared, and how many x's are left over is x squared. Now just be a little careful because there was a negative sign here. So it's a negative 2, but then there's already a negative, so really it becomes positive 2x squared times the cube root of 5x squared. All right, so notice that I always copy down my index on all these problems. That's really important to have that there. Because if you don't have it there, what does it mean? It means square root of 5x squared. But that's not what we have. We have a cube root of 5x squared.